Let's see what happens with permissions when we create a new file and a new directory. So I will create a file, a directory, and you can see that the file and the directory have been created with an initial set of permissions. But where do those permissions come from? Well, when you create a, a directory or a file, the initial permissions are different. For directories, the initial set of permission is 777. 777, remember that, that means that 7 is read, write, and execute permission, read, write, and execute permission, and read, write, and execute permission. So when we create a directory, in theory, we should have all permissions for all users, all the users of the machine. But you can see here that there is a permission missing. This is a 6 permission. This is not. This is a 5 permission. This is not a 6 permission. So what has happened? Why it is not having a 777 permissions here? Because before applying that permissions, we subtract some permissions here. We apply a mask here. We apply a mask, and some permissions are removed. What permissions are removed? That depends on the umask. You can define the umask for the system, and this mask, in this mask, you will put a 1 for the set of permissions that you want to remove. So for example, if I want to remove this permission, I will put a 1 here, and all the rest will be 0. 0, 0, 0, sorry, 1 and 0. And the final permissions that will be applied, if I have a 0, this is an XOR operation. So it will be 1, 1, 1, 1, 1, 1, 1, and an XOR operation means that 1 and 1 will be 0, and 1 and 0 will be 1, okay, as the rest of the permissions. So the final permissions will be 7, 7, 5, okay, because with the umask we have removed that permissions. We can check the umask with the umask order. This order, you have four octal digits. We will see the meaning of the first octal digit later. We are working with the last 3 one, and as you can see, the umask is 2, so this bit will be removed from the final permissions for directory. The same happens for files, but files are not created with 777 permissions, but 666 permission. So if I want to create a file, it's created with 666 permission. In this case, it won't have execute permissions by default, and if we apply the umask, the same umask is applied for files and directory. In this case, it will be 6. It will be 1, 1, 0, 1, 1, 0, 1, 0, 0. So user will be able to read and write, group will be able to read and write, and other users will be able only to read the contents of the file. So this is the final set of permissions that we have here. But we can modify the umask. So for example, imagine that we want to create the new files without permissions for the group. In this case, I will modify the umask. So if I want to filter all the permissions for the group, the mask will be 1, 1, 1 here. And imagine that I won't filter anything for the others. So in this case, the umask will be 0, 7, 0. And this mask will be applied to 777 in the case of directories, or 666 in the case of the files. That is a setting that is made system-wide, and it's always 777 and 666 for directories and for files. So I can modify the umask just with a new octal number. So for example, we want 070. Remember that we are working with the three last digits. 070. This is the new umask. So the files and the directory already created won't change the permissions, but if I create a new file, I can see here that the new file, this one, the new file, I don't have any permissions for the group because have been filtered by the umask. And the same for directories. If I create a new directory, I can see that the new directory hasn't filtered any permissions for the other users, but has filtered all the permissions for the group. Because in the umask, remember the umask we have said is don't filter anything for other users and filter all the permissions for the group. So the umask allows us to decide what permissions the system will use for creating new files and new directories.